Math 3, Unit 3, Semester Final Review. This unit, we need to remember how to factor using sum and differences of cubes. Most of you remember that we used SOAP. The first sign is the same as your original problem. The second sign is always the opposite sign of your original problem. And the last sign is always positive. Okay, so we're going to start with some examples. When you're dealing with cubes, everything has to be written as a cube. So how can I write 27 as a cube? 3. Very good. 3 cubed, x cubed, plus and 64 would be?
4 cubed.
Very good. Now, once you have everything as a cube, your first parenthesis is everything without the cubes. So we just drop the cubes off and we get 3x plus 4. You guys remember this?
Yes. I do.
Now, to get the trinomial part, so the next part is 3 terms. What we do is we write 3x 3 times, so 3x times 3x times 3x. And we write 4 3 times, 4 times 4 times 4. Who remembers what we do now? Very good. You group them into 2's, and each of these groups multiply to make each of those 3 terms. So, what will be my first term in the trinomial?
9x squared.
Very good. Now, my sign is going to be what?
Minus.
Good. Opposite of what's here? Minus. And then 3x times 4 is?
Plus. Always positive.
Perfect. There's your answer.
Oh, thank God. Don't have to do anything else.
Okay. So now we're going to try B. How do I write 125 as a cube?
5 cubed.
5, mate. 5.
X is already as a cube. Minus, and then 8 is 2 cubed. So what will my first parenthesis be?
5x minus 2.
Mate.
You guys are awesome. Okay, what is my next step?
Write them all out.
5x.
5x.
And you don't have to worry about positives and negatives. You're just writing this one 3 times and this one 3 times. Don't forget, though, that before you can do that, these have to be written as cubes first. Okay? So you have to change these numbers to be cubes. All right. So now we will group these in 2's. What will my first term be?
24x squared.
Good. 25x squared. And my sign now will be?
Plus, mate.
Good. 5x times 2 is?
10x.
And 2 times 2 makes?
4.
And that's my answer for factor. Okay, any questions? Good. Okay, next. This has multiple steps.
Well, this is the whoop de doo bricks and box, the whoop de doo. I'll make an equation for line, but
I'm not sure. You can tell me after we do the first example. Okay, so the first thing we're going to do, actually it's on the next page, what you're talking about, the graph. Okay, this is, we're just going to practice factoring. Whenever you have 3 terms, you always check for a GCF first. Is there a GCF?
No.
No. Then, if there isn't, you're going to check to see if you can factor a trinomial without the quadratic formula, because the quadratic formula is way more complicated. So, this is where we check our multiplication number and our adding number. So, my multiplication number is really 1 times negative 36, which is negative 36, and my adding number is, which numbers work?
9 and 4.
Very good. Specifically, though,
Negative 9, positive 4.
negative 9 and positive 4. Now, can I use the shortcut on this method?
Yes.
How do you know I can use the shortcut?
because there is no number.
Very good. There is no coefficient in front of your highest exponent term. Okay? So, we are going to make our 2 parentheses, but
Yes, be x squared. X squared.
Very good, Talon. So since it's x to the fourth, we're splitting it into x squared and x squared. When it's x squared, we split it into x and x. If it was x to the sixth power, we would split it into
X cubed, X cubed.
very good. Okay, and then one has a -9 and one has a +4.
Those are both perfect squares.
Wait, you don't have to put X in.
Okay,
Those are both perfect squares.
this is called a what?
Perfect squares.
No,
Difference
Try
of
is 3.
two squares.
A binomial.
2 squares. Difference.
Of squares.
Shh. Difference means subtracting. This will work. So 9, we would actually change 9 to be 3 squared, and how would I factor that?
X plus 4 is 3x.
That's fine. And can I factor x squared plus 4?
No, you can't because it's positive.
It's not a difference of squares, so you cannot. Okay? Now, this is factored completely. Oh, this is g of x. So g of x equals this. This is my answer for A. B says, B now says, find all of the roots, real and imaginary. What does that mean?
Set them equal to 0.
When I set this equal to 0, what does it equal? When I set the next one equal to 0, it equals? Now this one is a different story because it's x squared plus 4. So I'm going to do some work to the side. X squared plus 4 equals 0. What will I do?
Subtract 4.
Good.
And then you square root it.
X squared equals -4. I take the square root of both sides. Anytime I take a square root, my answer is going to be,
Plus or minus
and this is going to become what?
2i.
2i. So my real and imaginary roots are right there. -3, +3, and plus or minus 2i. Okay, then C says, how many x-intercepts?
2.
2 is correct. Why is it not 4?
Because there's 4 options.
Well, there's actually 4, because 2i and -2i.
2 i's in the real number.
It's an imaginary number.
Good. So the only 2 that would actually be on the graph are -3 and 3. Imaginary numbers are not on your graph, which means they are not x-intercepts. Any questions? Okay, so D, I'm going to go through this one a little bit more quickly. Are you guys ready? So on A, when you factor this one, it's going to be x squared plus 100 and x squared minus 1. Can either of those be factored further?
Yes.
X plus 1, X minus 1.
Good. X plus 1 and x minus 1, because remember that 1 is a square. 1 times 1 is still 1. So what would be my zeros on this one?
-1, +1, and 10.
Plus or minus
10.
10i. Very good. And how many x-intercepts?
2.
Any questions? Same process for finding that 10i would be taking your x squared plus 100, setting it equal to 0. We're just not going to go through that process for time's sake. Okay, E. Are you ready for E?
No.
Okay. Did someone say no? Okay. Do you guys remember what to do with this?
This is the fancy new stuff I'm talking about.
This is, it starts with an S.
Remember you can go in the box.
Yes, very good. This is called synthetic division.
Oh, I remember this. You bring it down.
Kill me now.
Okay.
Same.
What number is going to go in my little box?
+4.
Very good. Because we would set this equal to 0, and we would get a +4. What numbers go up here? 1,
-7.
2.
Oh, bring the 1 down. Then you
Good.
add
Oh my
the
God.
1 to the 4.
Okay. Now remember to be careful. in that this goes in descending order. Because if it went from an exponent of 3 to an exponent of 1, you would have to put a place marker of 0 in. Okay?
That's what I got.
So, the first thing we do, and I heard a lot of you say this, is bring down the 1. What do you do with that 1 now?
Multiply to the 4 and then put the 4
Good.
to the negative.
1 times 4 is 4, and then you just add down. And negative 7 and 4 makes
3.
and negative 3 times 4 is, and you add down and you get,
Negative 10.
and then you multiply and you get,
Negative 40.
and you add down and you get.
0. It works
Okay.
out.
Now you can factor this further. See if you can rewrite that out and factor it further.
Stop leaving.
Okay, watch the video later.
Ruining class.
Okay. Yes, Max.
Oh, I want to answer. I want to answer the next question you had.
Okay. What do I write? How do I write this?
X squared minus 3x minus 10.
X squared minus 3x minus 10. Now, how did I get that? What do I do?
You take an exponent away from the original function.
Exactly. So do you see here how this is x to the third? You go down by 1.
So square.
X squared. And then from there you go down by 1, minus 3x, and then minus 10. It should be in descending order, going down by 1 exponent every time. Now what you need to be careful of is that this is still part of your factored form. You still have your x minus 4 that you divided there. Now, did anybody check to see if this could be factored further?
Yes, it does.
Good. So what is our multiplication number? Negative 10, and my adding is, what numbers will work?
X minus 5, x plus 2.
Negative 5 and 2. So this right here, 1 and negative 10 is your negative 10 multiplication. The number in the middle is always your adding, which is negative 3. The numbers that multiply are negative 5 and 2. So that means that I end up with x minus 4. And can I do the shortcut on there?
Yeah.
So I end up with what?
X minus 5, x plus 2.
Good. X minus 5x plus 2. So it said find all the zeros. So what will be my zeros for this problem?
4, 5, negative 2.
What I find students doing is forgetting the 4.
I did that.
So here's the thing with the final. One of the answers will be 5 and negative 2. One of the answers will be 4, 5, and negative 2. You need to make sure to go back and check that you have all of the zeros. Is that clear?
There are always 3.
It depends. If you have a cubed power, there's usually 3 answers. If you had a 4th power, there would be, and so on. Good. Yes?
No, I was just trying to start the next question.
There's an error on the next question. This should have said negative 3, typo. Sorry. Okay, now what you're going to, yes?
Oh, what are you going to keep this the same because it's already at 0 hours left?
You answered my question before I asked it. I love it. Okay, so the question that Talon was answering that I didn't ask was this one. If you notice here, you had x minus 4. So we had to set it equal to 0 to find the 0. Here, they're telling you that one of the zeros is negative 3. So you're not changing signs. You're keeping that the same. So negative 3 goes into your box. You only set the ones equal to 0 that it says like x minus 4 or whatever. Okay, what numbers will now go next to this?
1, 8, 9, negative
Perfect. 1, 8, 9, negative 18. Okay, we go through, we bring down the 1, and then we get negative 3, and that becomes,
5,
and then we multiply, and that becomes,
negative 15,
and then we add down, and we get,
negative 6,
and then we multiply, and we get,
18.
and my remainder is 0. If they're telling you something's a factor or something's a 0 and you don't get a 0 here, you made an error.
I know I did.
Okay? So, what if, because they want this in factored form, okay? So what should be my first factor?
X plus 3.
Very good. I'm so proud of you guys. X plus 3 is correct, because in order to get a minus 3 there, this needs to be x plus 3. Okay, what's going to be my other parenthesis?
X squared plus 5x minus 6.
You guys are awesome. Can I factor further?
Yeah.
Cole, please don't. Okay, what is my multiplication number?
Negative 6.
She tells me so much.
Adding is what?
5.
What numbers work?
Negative 6 and positive 6 and negative 1.
Positive 6, negative 1. Do we all agree that those multiply to make a negative 6 and add to make a positive 5? Okay, what about 3 and 2?
No.
No.
Why not?
Because
I
they
don't want
can't
to.
multiply to be a negative and add to be a positive.
Right. In order for them to add to be 5, they need to both be positive, but that doesn't multiply to be a negative 6. So that is why 3 and 2 will not work. It has to fit both requirements. Okay, it's like a puzzle. All right, so that means we can use our shortcut, and in these parentheses, I get x plus 6 and x minus 1. This says p of x, so I'm going to write p of x equals that, and all it asked for was factored form. It didn't ask for my zeros or roots, so this is my answer. Now again, on your test, they would have all of them in factored form. They wouldn't like give you some where there were zeros and some where they were factored. They're not going to trick you like that. So if you can see it's all in factored form, then you know that's how the answer is supposed to be. All right, any questions? Yes?
Why is that for the first take them out of the parentheses?
So this one said find the zeros. So when you're finding the zeros, once it's factored, you set them equal to 0. Those are where they intersect. This one said factored form, so we just left it like that. Okay. Any other questions?
Yeah, on the test, if we write that answer, I don't know, we write set equal to 0 and square both the x's, not sure.
So it's multiple choice. So like they will only have ones like this. So it won't give you answers where x equals something. Okay? All right.
Are you sure?
Yes. Graphing. We spent a lot of time on this when we were graphing.
I know this killed me.
And we're going to review it right now. And I think you guys will all remember it as we review. There are two things when you're graphing that you need to know at the beginning, and that is your degree and your leading coefficient. So remember that your degree, if it's odd, opposite, right? Odd means opposite endpoint, opposite end behaviors. Where if it's an even degree, they will go in the same direction. What does your leading coefficient tell you?
The number and if it'll be positive or negative on the right side.
Your right in behavior. So your leading coefficient tells you if it's positive, the right side goes up. If your leading coefficient is negative, the right side goes down. Okay? Once you know that, then you're able to do the other end behavior based on your degree. Okay, on this problem here, what is the degree?
Dose.
2.
0.
Okay,
Oh wait.
Oh yeah.
Oh, it is 4. He's right. It's 4.
4 is the correct answer. So you're adding exponents. You're basically trying to figure out what would be the highest exponent in here. And so it's 2 plus 1 plus 1, and the degree is 4. Your leading coefficient, go ahead.
It's 1.
So your leading coefficient has to do with your numbers in front of the x's. So this would be 1 squared, which is still 1. This would be 1. This would be 1. You multiply 1 times 1 times 1, and you get 1. Okay? So, we know that,
It goes in the same way.
good, even degree, same directions, and they're both going to end up going up because positive. All right, so we're going to go through this now. Are you ready? When you set this equal to 0, what is it one of your x-intercepts?
2.
Good. X equals 2. And will it be a bounce or a pass?
The bounce.
How do you know?
It's squared.
Good. Even degrees. Multiplicity of 2. Bounce. Okay, this is going to be x equals what?
-1.
Bounce or pass? Very good, because it's an odd degree. Odd degrees pass, even degrees bounce. Okay, this will make x equals?
-4.
And bounce or pass? Very good. So we're going to go over to our graph. I'm going to put a point at 2, and I'm going to put a B there to remind myself it bounces. I'm going to make a point at -1. I'm going to put a P for passing, and then we have -4. Again, point, P for pass. Okay, the right side should go which way?
Positive.
Positive, and the left side should also go. And now we're going to try to fill in the rest. This is a bounce, so it bounces and it comes up, but it looks like it's going to have to hit the y-axis, which means we need the y-intercept. Do you guys remember how to find the y-intercept? Perfect. You plug in 0 into the equation and solve for y. So instead of writing f of x, I'm just writing y equals, and then we go 0 minus 2, I'm plugging in 0 for x, 0 minus 2 squared, times 0 plus 1, times 0 plus 4. What is 0 minus 2? And what is -2 squared?
4.
Good. And what is 0 plus 1?
1.
And what is 0 plus 4? And you multiply that all together and you get y equals what?
16.
So my y-intercept is just up here at 16. So now I can go ahead and finish my graph. It goes through 16, it passes through there, turns around, and passes back through. Any questions there? All right, we're going to try another one. Yes? So bounce is your exponent if it's an even exponent. Okay? And then pass is odd. Okay, H. Is this one ready to find all of our x-intercepts?
No.
What do I need to do?
Factor.
Good. So we have to factor this portion right here. So what multiplies to be -15 and adds to be 2?
5 and -3.
Good. 5 and -3. So Wyatt, are you getting this? All right. So we get x plus 5 and x minus 3. And I have another x minus 3.
So you can write it as squared.
And not you can, you should. And why should I?
It makes it easy.
Because of your bouncing and passing. If you don't write this as x minus 3 squared, there's a really good chance that you are not going to write that as a bounce. So always check to see if you have anything that duplicates. Okay? So I actually have x plus 5 and x minus 3 squared. What is my degree for this problem?
2.
Incorrect. 3. Why is it 3? Okay, so your degree comes from those exponents. If there isn't an exponent, it's a 1. You're basically trying to figure out what is your highest x exponent. Okay? So if you were to multiply it all out, you would end up with an x to the 3rd. The degree is 3. What will my leading coefficient be?
4.
Very good. 1 is correct. Because here you have a 1 in front here, a 1 in front here. 1 squared is 1 times 1 is still 1. Now we're going to try graphing. We're going to set each of these equal to 0. I'm going to get x equals what? Good. And is that pass or bounce? How do you know? Good. Odd degree. Okay, this is going to be x equals 3. And it's going to be a bounce. And also, this is called multiplicity of 2. This is called multiplicity of 1. Okay, so now let's go graph. We are going to put a point at 3 and a B to remind us to bounce, and a point at -5, and a P to remind us to pass. My right in behavior is going to go which direction? And we know that why? Leading coefficient's positive. My left end behavior is going to go, and I know that because odd degree, odd is opposite. Next, I start to graph. This is a bounce. I go up and I realize I have no y-intercept. Good. So, I'm sorry. Okay, so for my y-intercept, you can use any of these equations. You could use the first one, the second one, the third one. I'm going to go here because I think it's easiest, but it doesn't matter. So we go y equals 0 plus 5 times 0 minus 3 squared. 0 plus 5 is 5. 0 minus 3 is negative 3, and negative 3 squared is 9, and you multiply and you get 45. So, y-axis, there's a point, it's at 45. And then you can finish by touching here and passing through. Any questions? You can go crack the windows. Or tell somebody. Matt, will you open that window just a little bit? Okay.
Can I open this one?
Yes. Okay. This one is not factored at all. Sure. Oh yeah, back on the other one? Okay. Question, please listen. You need to use the x plus 5x. If you use the quadratic formula, you would end up getting the same answers though, but it'd take you a lot longer. So I guess you could use it. You'd end up getting x equals 5 and x equals negative 3 when you simplify through. And then you have to realize that you have two negative 3's, which means it's multiplicity of 2, which is a bounce. Okay? All right. We need to stop talking. Okay. Here we go. This one is not factored at all. When you are factoring, what do we always check for first? GCF. Is there a GCF?
X squared.
X squared, and then what am I left with?
X squared minus 6x plus 9.
Very good.
Oh, dang, that's so cool.
Okay, now we need to check and factor further. Okay, what multiplies to be 9 and adds to be negative 6?
Negative 3, negative 3.
Perfect. Okay, so we get x squared. How do you want to write that?
X minus 3 squared.
Can we just go right to writing that as x minus 3 squared because we know we have two of the exact same thing? If not, if you had written it twice, that's fine, but then you need to write it squared. Okay, so this was x minus 3, which is the same thing as x minus 3 squared. Okay, so we set these equal to 0. What does this one equal?
0.
X equals 0. X can equal 0. Okay, is it a pass or a bounce?
Bounce.
Why is it a bounce?
Because it's squared.
Good, multiplicity of 2, or it's squared. Okay, this one is going to be x equals what?
9.
3. And is it pass or bounce?
Bounce.
And again, why is it a bounce? Multiplicity of 2. Okay, what is my degree?
4.
The degree is 4. If you look back here when it's all multiplied out, that's your highest exponent. It's a degree of 4. If you look in your factored form, you would go 2 plus 2, also 4. Leading coefficient is always in front of your highest exponent. In this case, my leading coefficient is 1. If I go back here and figure it out, it's still 1. Okay, we're going to make a point at 0, and that's a bounce. We're going to make a point at 3, and that is a bounce. My right end behavior is going which direction? Up. Good. My left end behavior? Up. Okay, it bounces, turns around, and it bounces. Do I have to find my y-intercept on this one?
No.
Very good. But it has a y-intercept, doesn't it? It is at 0. Very good. Any questions here? Okay, this next part, they give you the graph. You have to write the equation.
Oh, that's fun.
Okay, so let's talk through this.
Shut up.
First of all, you'll notice that this one is a passing through, and this one is a bounce. We're going to try writing this out. Y equals, we have no idea what the A value is right now, so I'm going to put an A there. And then we are going to, what's going to be in my parentheses?
X plus 1.
Good, x plus 1. And then my next parenthesis will be what?
X minus 4.
X minus 4 what?
Squared.
Squared. How do you know it's squared?
Bounce.
Because of the bounce, the multiplicity of 2.
The right is positive.
Now, very good. So we know, and it should be an odd degree because they're going in opposite directions. Our leading coefficient should be positive because the right side is going up. But I need to know what my leading coefficient is in order to write the correct equation. You have to use a point on your graph. In this case, the only point I can use right there is at 0, 12. I can't use any of the points on my x-axis. Okay, the reason is if I did, it would give me a 0 and everything would cancel out. So in order to find the A value, it can't be an x-intercept. So we are going to plug this in.
What is wrong with that?
We're having bell system issues. Okay, so 0, 12. We're going to plug that in here. What do I do? What do I write? 12 equals A times 0 plus 1 times 0 minus 4 squared. And we're just going to solve for A. So we go through here. 0 plus 1 makes 1. 0 minus 4 is, and negative 4 squared is. When you multiply all that, we end up getting 16A. And then what do? Divide by 16 to both sides. You simplify, and A equals 3/4. So all we do is take that, plug that back in for A. And so my actual equation is Y equals 3/4 x plus 1 times x minus 4 squared. Perfect. Any questions? Okay, last example for today.
Works really bad.
Same thing here. Pay attention to what each of these are. Is that a pass or a bounce? Pass. This is a, and this is a pass. Also, this is our y-intercept, and that as an ordered pair is 0, 3. And I'm going to label them as x and y.
Even degrees.
Okay, so we're going to write our equation. Y equals, I'm going to put an A, because we don't know that yet. First parenthesis will be what?
X plus 3.
Good. Second parenthesis will be what? Squared. So pay attention to your passing and bouncing. And this one will be perfect. How do I find my A value? What do I do? Very good. Plug this in for x and y. So we will write this as 3 equals A times 0 plus 3 times 0 minus 1 squared times 0 minus 2. We then get 3 equals A times, what's 0 plus 3? Jenny. 0 minus 1 is? And negative 1 squared is? 1. And 0 minus 2 is? When you multiply all that together, what do you get? Negative 6A. And then we? And so A equals what? Negative 1/2. Does it make sense that it's negative? Yes.
Going down.
Very good. So my equation is y equals negative 1/2 x plus 3 x minus 1 squared times x minus 2.